Hi guys, welcome to Budget Power Electrical Solutions. Today we're looking at something very interesting. Imagine this motor is running, but the fan appears completely stopped. Would you trust your eyes? This strange effect is called the stroboscopic effect. In this video, I'll show you why it happens, why it can be dangerous, and how it is also used practically in industry. Now look closely at the motor. The shaft and fan are actually rotating continuously, but under certain flickering lights, the fan may appear stopped, moving very slowly, or even rotating backward. The important point is that the motor speed has not suddenly changed. What has changed is only what our eyes are seeing. So the next question is, why can a rotating fan look completely stationary? This visual illusion is called the stroboscopic effect. A rotating object is illuminated again and again by a pulsing light. If each flash catches the blade in nearly the same position, our eyes receive almost the same picture every time. Because of that repeated image, the brain can interpret the rotating fan as if it were standing still. To understand it more clearly, let's look at what is happening between those flashes. Think of the flickering light like a camera taking very fast snapshots. At the first flash, we see the blade in one position. The fan continues rotating, but then the next flash happens when the blade reaches nearly the same position again. Flash after flash, our eyes keep receiving similar snapshots. The movement between those flashes is not clearly seen. That is why the fan can appear stationary, even though the shaft is still rotating. But if the flash timing changes slightly, the picture changes again. This is where the effect becomes even more interesting. If the flashing light closely matches the repeating blade position, the fan can appear completely stopped. If the timing is slightly different, the fan may appear to move slowly forward. And with another small timing difference, it can even look as though it is rotating backward. The motor has not reversed. The apparent movement is created only by the relationship between the light flashes and the rotating blade. Now imagine this happening on real industrial equipment. In industry, this is not just an interesting optical illusion. Imagine a lathe chuck, drill, saw blade, fan, coupling, or motor shaft appearing completely stationary. A worker may think the machine has stopped and try to touch or adjust it, but the equipment may still be rotating at full speed. That is why the stroboscopic effect can create a serious safety hazard. We should never decide that a rotating machine has stopped only because it looks stopped. Interestingly, the same principle can also be used deliberately for measurement. A stroboscope uses this same effect in a controlled way. We aim the flashing light at a rotating shaft or marked disc and adjust the flash rate until the reference mark appears stationary. For a simple 1 flash per revolution condition, RPM equals 60 times the flash frequency. So, for example, 30 Hz corresponds to 1800 RPM. That gives us a useful non-contact method for checking rotational speed. So the same effect that can create a hazard can also become a valuable industrial tool. The key is understanding the effect and controlling the risk. Good industrial lighting with suitable high-frequency drivers can help reduce flicker. But even with good lighting, never depend only on visual appearance. Before touching rotating equipment, isolate the power, lock it out, and verify that the machine has actually stopped. The main lesson is simple. A machine that looks stopped may still be rotating. I hope this video helped you understand why a rotating motor or fan can appear stopped and why that matters in real industrial work. And always remember, around rotating equipment, verify before you touch. Thank you very much for watching Budget Power Electrical Solutions. If you found this useful, please like, share, and subscribe to the channel.